Hey everybody, this is Mrs. Costello. I'm going to be doing the day 9 video. You are definitely going to need your graphing calculator. If you don't have it, you might want to, locate it, pause the video, find it, because we are going to be working with our graphing calculator today. We are going to start off with some review. So I would like you to go ahead and take some time to pause your video and try the review on your own. When you unpause your video, you're going to see my work. So go ahead and pause your video now. Okay, so here's my work on some of those review problems. The first one was a word problem, and it really just asked us to set up the equation. Didn't even want us to solve. So here's the equation I set up right here. So our base is a square, and I kind of drew it over here. Here's my base, and I drew a little square right here. So my height of my sandbox is going to be, we don't know, it's X, but then it also said that each side should be 3 feet longer than the height. So all I had to do is take X plus 3, and there's 2 of them, so that's how I squared it and got the 16. Number 2 is a really good one for this unit because we're checking like, hey, you're looking at a picture of a graph. That's as far as I can zoom in on the graph. And we're finding the equation, even if we don't really know like what the equation is. I used the zeros, -1, 0, and 3, and picked answer choice C. If you have questions on these, you should ask your teacher tomorrow in class. All right, so we have a vocab box. We're pretty much doing a lot of the same thing. Today, just the only new part is this, okay, how many solutions do I have? How many, how many times is it repeated? Because I believe like we've already kind of talked about how many solutions we would have. Or no, maybe that's later. Never mind, we're going to talk about that today. But we're going to talk about repeated solutions. So if, this is something you should probably write down, a parentheses is raised to a power the solution repeats. I'm trying not to get on that other line, so I'm sorry. The solution repeats. Okay. And you're going to we'll kind of talk about this a little bit in those 2 problems that are right there. Then we have something called multiplicity. So multiplicity tells me how many times that solution repeats. So that's what we're going to put right here. How many, come on, there we go, times the solution repeats. There we go. Right. Now we kind of talked about zeros in the graph, right? In the graph, the zeros were the x-intercepts. But in day 7, I think we talked about like imaginary versus rational and real and stuff. Only the rational or the real zeros are going to appear as the x-intercept. So if you have an imaginary solution, you're not going to see it in your graph. It's going to be like above the axes, or you're just not going to see it. If a factor x minus k of a function is raised to an odd power, okay, then the graph's going to cross the x-axis there, right? And then like if it's raised to an even power, so this is for the multiplicity. If it's raised to an even power, what it does is it touches the x-axis and then it turns like right back around. So let's say I had a parabola that looks like this, and it touches the x-axis and then goes up. This 0 right here is repeated, so it has a multiplicity. So you're only going to see like 1 0, and we're used to solving these, but all it does is it touches and goes right back up. So number 1 and number 2 want you to state the zeros of each function and then the multiplicity of each 0, and it wants you to verify by graphing. I'm going to leave you guys to do this part on your own, the graphing part in your graphing calculator. And you can kind of see that a little bit. I'm not going to show it when I answer the questions. But you guys could totally do that part on your own. So the zeros, right? Everywhere there's an x is a 0. So there's 2 zeros. Okay. Right here I have a 0 at x equals 2. And then I have a 0 here at x equals -1. Now that -2 is being raised to a power, right? Look right here. I have a squared. So that means I have a multiplicity of 2. So that's my new part. I have to now state that. So I put multiplicity of 2. So that's kind of where it, it touches and goes back up. Again, you can kind of see that on your own. Now this x equals -1, there's no exponent by the parenthesis. So it just has a multiplicity of 1. Come on. There we go. All right. So same thing on number 2. Everywhere there's an x, there's a 0. So my first 0 would be x equals -2. There is no exponent, so it just has a multiplicity of 1. And then the second one, right? X equals 3 would be the 0 here. And it has a multiplicity of 4 because that's what the exponent is. Right. We have one more vocab box, and then we're doing a bunch of problems for the rest of the time. So the fundamental theorem of algebra tells me if my polynomial has a degree and the degree is not 0. Okay, so n is my degree, it's not 0. It has at least one rational solution. Okay, so that means like I will for sure have at least 1 0 that I can see on the graph, for sure. Okay. Now a corollary is just kind of like, an add-on. So the polynomial function of degree n has exactly n solutions, including like repeated solutions. So whatever the like exponent is, that's how many solutions I'm gonna have. And we're gonna kind of look at that in number 1 and number 2. So all it asks you to do is to find the number of solutions or zeros for each function. So all you're looking at is the biggest degree. So on number 1, my biggest degree in here, if I kind of look at it, is definitely this x cubed, right? So I would definitely write down that it has a degree of 3, which means I have 3 solutions. That's it. And that's going to be really important when I do number 3 and number 4, and I'll show you why. Okay. Same thing on number 2. So my biggest exponent is right here, this x to the 4th. So this is a degree 4, which means it has 4 solutions. All right. So here's where this is going to come in handy. On number 3, it asks us to find all the zeros for the function below. This is a big function. So what I'm going to do is I'm not going to start grouping. I mean, if you really, really want to, go for it. Group them, have fun, whatever. What I'm going to do is I'm going to look at my degree, my leading coefficient my biggest exponent is 5. So I know I am going to have 5 zeros for sure on number 3. They might be real, they might be imaginary, I don't know. What I'm going to do, because I don't know what that looks like, I don't even want to find the zeros by hand, is I'm going to get the zeros from a calculator. So right now, I'm going to put this whole function in my calculator. Okay, so here's my graph right now. So I put that whole thing in, I graphed it in my graphing calculator, and if I'm looking at this, I have a couple zeros that I can for sure see. My screen doesn't really let me draw on this this is kind of a ghetto graphing calculator, but I for sure have zeros at -1 right here. And do you see how it touches and then it just goes right back down? That means that it's a multiplicity of 2. So I'm definitely going to keep that in mind. So -1 multiplicity 2. 2 is another 0, but it just goes straight through. So I don't think it might have a multiplicity of 2, but it's really hard to tell because if it does, it's not being raised to an even power, it's being raised to an odd. We're just going to assume it's just ones. We're just going to assume that. So we're going to go back to our page now. I'm going to write these down. So from the calculator, I had zeros at -1 and 2. Like, I could for sure see those. That doesn't mean that I don't have other zeros. They just might be imaginary. They probably are imaginary. Okay. And then this is my times 2, at least. So we're going to use these zeros, do some synthetic division to find my other zeros, because I'm not finding it with that long equation right here. So let's set up our synthetic division. So I'm going to start with -1, since I know that's a 0. I know it's a multiplicity, whatever. Coefficients: 1, -4, 4, 10, -13. Yikes, I'm running out of room. And -14. I'll just erase this. I'll write the times 2 right there. Perfect. Okay, synthetic division. So I'm going to bring down my 1. 1 times -1 is -1. Add down, -4 and -1 is -5. -5 times -1 is +5. Add again, 4 plus 5 is 9. 9 times -1 is -9. 10 minus 9 is 1. 1 times -1 is -1. 13 and -1 is -14. 14 times -1 is +14. And no remainder. That definitely should happen if you use a 0 from your calculator. If you get a remainder, you did something wrong. Okay? So that's just one round. I'm going to do another round of synthetic division because I need 5 zeros. So I have for sure 3, so I need 2 more. So I'm going to keep breaking this down into, I'm going to use all these and hopefully I'll get to a quadratic, which I'm pretty sure I will. Because this guy is an x to the 4th. So I'm already down to a 4th. So now I need to get to a quadratic, so x squared. You can use -1 again because there's 2 of them, and that's exactly what we're going to do. So we're going to use -1 twice. So I'm going to use the coefficients from here. So 1, -5, 9, 1, and -14. We're going to do it all over again. Bring down the 1. 1 times -1 is -1. -5 plus -1 is -6. -6 times -1 is +6. 9 and 6 is 15. 15 times -1 is -15. 1 minus 15 is 14. -14 times -1 is +14. And again, I get a remainder. Perfect. So I'm down to x cubed. Let's do one more time. This time I'm going to use my other 0, which is a 2. So 2 goes here, and then the coefficients from above go in. 1, -6, 15, -14. Okay, we're getting there. Bring down the 1. This is my x squared term. That's going to be perfect. 2 times 1 is 2. -6 plus 2 is -4. 2 times -4 is -8. 15 minus 8 is 7. 7 times 2 is 14. Sweet. Okay. So I used my zeros. Now I have a quadratic equation. X squared minus 4x plus 7. Now I'm going to find the zeros from here. Usually we would totally check, see if we can factor. Spoiler alert, we cannot. Okay, that was really hard to say, so sorry. Okay, but I just thought it was going to sound cool. It did not. Kind of sad. It's okay. So next to it, if you didn't, use all of your room like I did, we are going to do a quadratic formula. I know, you're so excited. It's your favorite for this equation. Okay, to find my other zeros. So this is A, B, C. So my zeros, right? X equals -b, so 4 plus or minus square root of -4 squared. minus 4 times a is 1, c is 7, all over 2 times a, and a is just 1, so you can write 2. All right. Put this whole guy in your calculator because then you don't have to worry about things. Just to save some time, I'm just going to tell you what it is. This is going to be 16. This is going to be negative 28. So you have negative 12 underneath your radical. I told you, imaginary. Okay, so yeah, we got some imaginary guys in there. All right, we definitely are going to take out an I, and we got to factor this 12 down. 12 is 4 times 3. 4 breaks down to 2 times 2. So x equals 4 plus or minus 2i, and then the 3 stays on the inside, all over 2. Simplify that guy because you can simplify your outside numbers only. So they can all be divided by 2. So x equals 2 plus or minus I root 3. That's 2 zeros right there because of this plus or minus. 2 plus I square root 3, 2 minus I square root 3. 2 zeros, and then also you need to include your other zeros. So negative 1, oops, not highlighter, sorry, hold on. There we go. Negative 1 and 2. You don't really have to put in your zeros the multiplicity. It's just important for the synthetic division. So number 4, we're going to do the exact same thing. So put this in your graphing calculator and then do the y equals, push graph. Maybe pause your video to take a second to do that because I got to set mine up anyways. And then when you unpause, you're going to see mine in the calculator. Okay, so go ahead and pause your video. All right, so here's my graph. Just like the last time, I got a couple zeros. So negative 2 is definitely a 0 because it goes through the axis at negative 2. And then 1 has that multiplicity because it touches and then goes right back up. So it never crosses, it just touches. Another way you could find your zeros is in your table. Now I know that my calculator is a little different, but basically, like, see how mine, I have the equation. I know there's a function in your calculator where you can find a table, so I'm gonna go in the table, and this is another way you could totally find the zeros. So like 1 is definitely a 0, negative 2 is a 0, if you didn't want to have to like look through it. So we have technically 3 zeros because remember 1 has a multiplicity of 2. And let's write down zeros from your calculator. Negative 2 and 1. And remember the 1 is a multiplicity of 2, so put times 2. Because you're going to do your synthetic division again 3 times. Because you have your degree of 5, right? X to the 5th, so that means there's definitely 5 solutions. Okay? Why don't you go ahead and pause your video and do your synthetic division 3 times. So go ahead and pause your video now. Okay, I lied a little bit. I did 1 round of synthetic division. Even if you did it with the negative 2, I'm kind of stepping in because hopefully you remember to put a 0 in for the x cubed placeholder because your equation goes x to the 5th, x to the 4th, x squared. You're missing your x cubed, so make sure you got that in there. So this is 1 round of synthetic division. Again, you need to make sure you use 1 twice. Just, cutting in there. You go ahead and keep pausing your video, keep doing your synthetic division. Okay, so here's all my synthetic division work. I used all 3 zeros that I had, and I got it down to x squared minus 2x plus 3. Okay, so that's 3 zeros. Now it's down to something that I know how to solve. So you guessed it, you're pausing your video, you're doing it on your own because you guys can do it. Quadratic formula because it doesn't work. Sorry, I'm saving you the trouble. I was super optimistic, but it doesn't work. Okay, so go ahead and pause your video, do quadratic formula now. All right, so here's my super beautiful work for quadratic formula. Really, the only thing I really want you to make sure of is down where I have rainbow pen for x equals 2 plus or minus 2i radical 2, make sure you only reduce those outside 2's. Do not touch the inside radical 2 because you can't do that. So only reduce the outside guys on that one. And then in the pink is what you should have gotten for all your zeros. All right. We got one more. And then I'll leave you alone. Okay. Use your graphing calculator to approximate the real zeros of the function below, and then state the x-intercepts and the zeros. So we're going to take this guy, plug it into our graphing calculator, and then see the general shape of it and where the zeros might be. All right, so this is what the graph looks like, okay? The general shape of the graph. It looks like it's got like a really kind of bigger, bigger kind of local max at 9. So, sorry, I had to like zoom out a little, or zoom in a little bit to see that. So it's kind of a narrow graph if you look at it. And that's kind of what it's going to look like when we graph it by hand. So the max is at about 9, and we could have found that if we just plugged in 0. The zeros are not nice. And Mr. G won't buy me the nice calculator on my iPad, so you guys are going to have to calculate those. Good thing I already did it on, my own. But let's transfer this by hand to our other graph. Okay. So I did find the zeros, I promise you. The zeros are at negative 1.73 and 1.73. Okay. So if I'm putting that on my graph, just do your best. Like, okay, that's not 2, and that's not 2. Close enough, okay? And then I do have the max at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we'll just pretend it's right up here. That was a mess up. Okay. And we know the general shape of my graph looked like this. It was that W shape. Okay, it doesn't have to be perfect, just as long as it has that general shape. Okay. So the zeros, I already kind of wrote those down. Those are my x-intercepts. And then the multiplicity of each. So this graph is an x to the 4th, which means there should be 4 zeros, while both of these guys touch the axis and then go back up, which means they each have a multiplicity of 2. So write something along those lines. So both have a multiplicity of 2. And then it did say to explain the effect, and just say like this makes the graph touch the x-axis and then go back up. That's it. The graph and go back up. All right, so those problems take a while. I hope this video, helped. If you have questions, let your teacher know in class tomorrow. Otherwise, enjoy the rest of your day.